Okay, the next thing that I want to make note of before we jump into all of the individual problems is that when you have exponential growth and decay and you have logarithm equations, they look very similar, but they graph differently. So having, I'm going to copy one of them down, or sort of. Okay. When you have an equation, so you've got a function here, f of x simply means y, so you could rethink of it as y equals f to the x plus 1 in that case. I have a base. I have it raised to the exponent. I have it in my exponent form here. When it is in this form where you have base with your exponent, this is a growth and decay formula. Okay, so this is a growth and decay function. Okay. When we have already broken down this base raised to a power, and we've written it in the log. So we've done a flip of it basically. So this is one direction. Remember, everything has an opposite. So for example, this might be the positive side. Now we need to go to the negative side. Or this is the multiplication. Now we need to go to the division. And that flips things, right? What it actually does in a graph is that it flips it across a diagonal. That's just a side note. It flips it across y equals x. So in this case, we have it written in our exponent form. If we were to change this and write it where we've got our function is equal to log 5, let's make it, there we can get to 25 plus 1. Okay, so now I actually have a log, or we'll have the log in like this with an x where we don't know what the answer was for that. So now I'm not putting it in an exponent form. I'm putting it in a log form. When it is a log form, this is a log function, and they are graphed differently. So an exponential growth and decay function will always have a horizontal asymptote. And an asymptote is that line where your function gets really, really close to it, but it doesn't ever actually touch it. But it's kind of like that boundary line for your graph. So you're either going to have, you can have growth that way, you can have growth this way, you could do it that direction or this direction, but you're going to have this horizontal asymptote. So if you have a function that already sets up with your base to your exponent as a growth and decay function, you will always have a horizontal asymptote. Okay. Now, if you have the flip of it, so now you have your function and it starts out with the log. So this is giving you, remember, what is this giving you? This is giving you the exponent, right? So here, instead of finding the answer plus a number, you're finding an exponent plus something. So you're changing the exponents. This is you're changing your main answer. On this type, when it sets up as a log, you are always going to have a vertical asymptote. Okay? Remember, because we're flipping it. So in where we had a horizontal asymptote when we had it set up, where we found our answers, we are flipping it. Now we've got a vertical asymptote. So any log functions will always have a vertical asymptote. And then your function would move along that asymptote in the 4 different directions. Like that. Okay, so that's the most important thing to do. So we will ask ourselves questions as we work through these, and it will help us graph them without using a graphing calculator.